Equation of a plane in normal form. Listen, suppose there is a plane. See, just imagine x, y, z axis, x axis, y axis and z axis. P is a point in the plane and take a point N such that ON is the perpendicular. Okay, ON is the perpendicular from the origin to this plane. So let us take this distance as equal to d, and it is known as, this perpendicular distance is known as normal. Okay, so ON is the normal from the origin to this plane. Now along this plane or along this normal, define a unit vector n cap and join NP such that this angle is equal to 90 degree. Okay, always we join a point with a normal, angle should be 90 degree. Now take this center as O. P is a point and therefore OP is the position vector of the point P, and take it as vector R. Okay, so ON is the normal from the origin, NP is a perpendicular from normal to this point, and OR is the position vector of this point P with the coordinates x, y, z. Now see, ON and NP are perpendicular and therefore their dot product is equal to 0. So NP dot ON is equal to 0. Two lines are perpendicular means they are, suppose this is vector A, this is vector B, then their dot product is equal to 0. Okay. So in this triangle ONP, we can say that ON plus NP is equal to OP. Now what is ON? ON is, listen, ON is a normal and its distance, magnitude is D, and along this ON we define a normal, unit vector N. So vector ON can be written as, listen, distance into this unit vector. Please note down, normal vector can be written as distance into, magnitude into the unit vector along ON plus NP. Now listen, NP. What is NP? NP is the distance between N and P. Okay, equal to OP. OP is the position vector. So from here we can write NP is equal to R minus D into unit vector N. Okay, R into unit vector N. Now this value, put it here. So NP dot ON is equal to 0 implies NP is R minus DN dot ON. ON is D. Okay, D unit vector is equal to 0. Now listen, this can be written as R minus D into N cap dot N cap is equal to 0, because we are taking dot product, so there is no change in the magnitude. So in this case, in the case of normal, we can write R minus Dn dot Dn is same as R minus Dn dot Dn. Now taking dot product, we can see that R dot N minus D into N dot N is equal to 0. N is a unit vector and therefore dot product is equal to 1. So R minus N minus D is equal to 0, or R minus N is equal to equal to D. So this is the required vector equation. Listen, vector equation of the plane. So you have to by heart all these result only. Vector equation of the plane is equal to R minus N is equal to D. So here R is the position vector, N is the unit vector, and D is the perpendicular distance from the normal. Okay. Now see the Cartesian form of plane or Cartesian equation. Cartesian equation of the plane. Cartesian form of the plane. Okay. Let us consider vector R, position vector, as xi plus yj plus zk, and the unit vector n as Li plus mj plus nk. Here L, M, N are direction cosines. Okay. So the vector equation r dot n is equal to d becomes xi minus yj plus zk dot Li plus mj plus nk is equal to d, implies taking dot product, this gives Lx plus my plus nz is equal to d. Okay, so this is the Cartesian form. So you have to by heart vector equation r dot n is equal to d and Cartesian form Lx plus my plus nz equal to d. These two equations. Okay. See this example. Find the distance of the plane 2x minus 3y plus 4z minus 6 equal to 0 from the origin. See, equation of a plane is like this. Okay. X, y, z and constant term. 2x minus 3y plus 4z minus 6 equal to 0. So from the equation we can write easily the direction ratios. Okay, direction ratios. So direction ratios is the coefficient of x, y and z. So 2, minus 3, 4. These are the direction ratios. If we get direction ratios, we can easily write direction cosines. Okay, so direction cosines can be written as 2 by root of 2 square plus minus 3 square plus 4 square minus 3 by root of 2 square plus minus 3 square plus 4 square 4 by root of 2 square plus minus 3 square plus 4 square. So this is 2 by root of 29 minus 3 by root of 29 4 by root of 29. These are the direction cosines. Okay. So we have the equation 2x minus 3y plus 4z minus 6 equal to 0 or 2x minus 3y plus 4z is equal to 6. So we are going to dividing throughout by root of this 29. So listen, this is equal to 2x by root of 29 plus minus 3 by root of 29y plus 4 by root of 29z is equal to 6 by root of 29. So this is of the form, this is direction cosine L, Lx, this is, look at here, M, My, this is Z, N, Nz is equal to D. So this is the Cartesian form of the plane. So here what is D? D is equal to 6 by root of 29. So D is the distance from the origin to the normal. Okay, that is 6 by root of 29. Now next is equation of plane perpendicular to given vector and passing through a given point. Listen this space XYZ plane. So in this space there are many planes that are perpendicular to given vector. See, we can't draw all these planes, just imagine. Planes are mean just like a glass plane. Okay, so we can draw a lot of planes in a space and through this point P, given point P, okay, through this given point P, we can see only one plane is passing through this point P. Okay, only one plane can be passing through this point P. Okay, so suppose consider this plane. Okay, consider this plane passing through this point P and we have to see what is the equation or what is the equation of this particular plane perpendicular to given vector and passing through this point P, X, Y, Z. Okay, so let us consider the required point P with the coordinates X, Y, Z and N is the normal. Okay, N is the normal and A is any point in this plane. Okay, A is any point plane and position vector of A is equal to vector A. Now listen, this is our required point. So let us consider position vector of P as or OP as vector R. This point P is lies in the plane if this AP is perpendicular to N. It's very important. This point P is inside this plane only if this perpendicular, this vector N is perpendicular to the vector AP. So vector AP dot vector N is equal to 0. From here we can deduce the vector equation as R minus A dot N equal to 0. You have to by heart only this, that's enough. Vector equation of the plane when a given vector and passing through a point is R minus A is equal, R minus A dot N is equal to 0. Okay, R minus A dot N is equal to 0. Here N is the given vector, perpendicular vector. Okay, R is the position vector and A is the vector of a point in the given plane. Now see its Cartesian form. If we consider this as xi plus yj plus zk and take A as point, n as point, n is the vector, ai plus bj plus ck, and A, position vector of A is x1i plus y1j plus z1k. Then put all these values here. We will see A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. This is the Cartesian form of a plane perpendicular to a given vector and passing through a point. Okay. To study vector equation and Cartesian equation. So vector equation is R minus A dot N is equal to 0. Okay, R minus A dot N equal to 0, and Cartesian equation is A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Okay, let's see an example. Suppose we have a plane which passes through the point 5, 2, minus 4. This is the point, and perpendicular to the line with the direction ratios 2, 3, minus 1. So we have a point. Okay, we have a point and we need a vector perpendicular to this plane. So this line is given with the direction ratios 2, 3, minus 1. So from here we can write the vector perpendicular to the plane as, listen, 2i plus 3j minus k, because direction ratios are given. So this is our perpendicular vector n. Okay, n is perpendicular to the plane. Now what is the vector equation? Vector equation is R minus A dot n is equal to 0. So R is the position vector. Position vector of this point means vector equation of the plane is R minus A dot n is equal to 0. R is the position vector, that is xi minus yj plus zk. There is no change in the position vector in each and every question. Okay, minus A. A is listen, the given point is 5, then 2 minus 4. So from here we can write A, that is 5i plus 2j minus 4k, and n is we define already 2i, this dot 2i plus 3j minus k is equal to 0. Now this is x minus 5i plus y minus 2j plus z minus 4, that is z plus 4k dot 2i plus 3j minus k is equal to 0. Now take the dot product, x minus 5 into 2 or 2 into x minus 5 y minus 2 into 3 or 3 into y minus 2. Z plus 4 into minus 1 or minus 1 into z plus 4 is equal to 0. Now open the bracket. 2x plus 3y minus z minus 10 minus 6 minus 4. Minus 10 minus 6 minus 16 minus 4 minus 20 is equal to 0, or 2x plus 3y minus z is equal to 20. So this is the vector equation. This is a Cartesian equation. Okay, Cartesian form. So r minus a dot n, this is the vector equation. From here we can deduce its Cartesian form also. So in this manner we can see the problems. Okay, through three non-collinear points. Suppose we have three non-collinear points A, B, C, and this is the origin. So from this origin draw vectors to these points. Let us consider position vector of A is vector A, position vector of B is vector B, position vector C as vector C. So we can write the vector equation of this plane passing through this point as, listen, r minus a dot b minus a cross c minus a is equal to 0. Okay, r minus a dot b minus a cross c minus a is equal to 0. This is the vector equation, and the Cartesian form is, listen, suppose this is the point x1 y1, this is the point x2 y2, this is the point x3 y3. Okay, x1 y1 z1, x2 y2 z2, x3 y3 z3. Then the Cartesian form is x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, then x3 minus x1, y3 minus y1, then z3 minus z1 is equal to 0. Okay, so this is the Cartesian form. Suppose we have 3 points 2, 5, minus 3, minus 2, minus 3, 5, 5, 3, minus 3. These are the 3 non-collinear points. So the vector equation can be written as, so here write the vector. Vector is 2y plus 5j minus 3k. This is vector A. And from here minus 2y minus 3j plus 5k. This is vector B. 5y plus 3j minus 3k. This is vector C. So vector equation is r minus a dot b minus a cross c minus a c. So we have to see b minus a, c minus a, then their cross product, and again taking with dot product with r minus a. This gives our vector equation. Okay. At the same time, Cartesian equation is, let us consider this is x1, y1, z1, x2, y2, z2, x3, y3, z3, and put all these values here and find the determinant, which implies the Cartesian equation. Okay.